The speed of light is not merely a velocity, it is the absolute horizon of information, the structural rule that prevents cause and effect from colliding. For over a century, physics treated this boundary as inviolable, but hidden inside the mathematics of relativity is a persistent anomaly, the tachyon, a theoretical particle not created by breaking the limit but by existing entirely beyond it. If such an entity could interact with our causal sector, the order of time itself would no longer be fixed. Messages might arrive before they are sent. The sequence of cause and effect could reverse. Recently, a proposed framework from physicists at Oxford and Warsaw suggests a way to confront this paradox without tearing reality apart. Yet one question remains: what if the laws of physics are not universal, only local? To understand whether the laws of physics are universal or merely local, we must start with the rule that enforces order itself. The universe operates on a single, non-negotiable, constant 299,792,458 meters per second. We call it the speed of light, but a more accurate forensic term would be the information horizon. This figure is not merely the velocity of photons traveling through a vacuum, it is the fundamental bandwidth limit of spacetime itself. It dictates the maximum speed at which any interaction from electromagnetic signals to gravitational influence, or even raw information, can propagate across the cosmos. In the architecture of special relativity, this limit is the glue that holds reality together. It ensures that a cause always precedes its effect, preserving the logical sequence of events that we perceive as time. For any object possessing positive mass from a single electron to a starship, this horizon acts as an infinite barrier. To accelerate an object to the speed of light would require an infinite amount of energy, a feat that is physically impossible within the known laws of thermodynamics. As velocity increases, mass effectively increases, becoming heavier and harder to push until the system locks up against the barrier of c. For over a century, physics has treated this as a closed case. The barrier is absolute, and nothing can cross it. However, a closer forensic analysis of Einstein's equations reveals a subtle jurisdictional loophole. The laws of relativity forbid accelerating across the speed of light, but they do not technically forbid moving faster than it. The mathematics implies that if a particle were never at rest, if it were born instantly on the other side of the barrier already traveling faster than light, it would not violate the energy constraints of acceleration. It would simply exist in a different state of reality. To understand the tachyon, we must abandon our intuitive understanding of motion. In our forensic analysis of the physical world, the subliminal sector, we observe a strict correlation between energy and speed. If you want to accelerate a vehicle, you must burn fuel. To go faster, you add energy. To reach the speed of light, you would need infinite energy. This is the kinetic law that governs everything from falling apples to orbiting galaxies. This is not a separate universe or hidden dimension, but a different mathematical regime, allowed by the same equations. But the equations of special relativity suggest a mirror sector, where these laws are not broken, but precisely inverted. In 1967, physicist Gerald Feinberg formalized the profile of this theoretical anomaly, coining the term tachyon from the Greek tachys, meaning swift. Feinberg realized that the math allowed for a particle to exist beyond the light barrier, provided it adhered to a bizarre set of energetic constraints. In this superluminal domain, the relationship between kinetic energy and velocity is flipped. For a tachyon, gaining speed does not require adding energy, it requires losing it. Imagine a car that accelerates as its fuel tank runs dry. Losing energy makes it move faster, adding energy makes it heavier and harder to slow. As a tachyon decelerates toward the speed of light from above, its energy requirements skyrocket toward infinity. Just as we cannot accelerate up to the speed of light, a tachyon can never decelerate down to it. The speed of light remains the absolute information horizon, a wall that separates these two domains. We are trapped on the slow side. They are trapped on the fast side. This behavior stems from a mathematical feature that often unsettles the uninitiated imaginary mass. In the standard energy equation, E equals gamma mc squared. If velocity v exceeds the speed of light, phi, the gamma factor, becomes an imaginary number, meaning it involves the square root of a negative value. In physics, energy must be a real and measurable quantity. You cannot have imaginary energy lighting up a detector. To balance the equation and keep energy real, the mass of the particle must also be imaginary. In forensic physics, imaginary mass m squared less than zero is not a claim that the particle is fictitious or a ghost. It is a structural flag. It describes a system with negative curvature in its potential energy, essentially a particle that is inherently unstable. This instability leads to the strangest characteristic of the suspect. For ordinary matter, the state of lowest energy, the ground state, is rest at zero velocity. For a tachyon, the state of lowest energy is infinite velocity. If a tachyon were to lose all its energy, it would not come to rest. It would become completely delocalized with no defined position in space-time. It is a particle that is energetically compelled to move a system that can only exist in a state of hyperacceleration. This kinetic inversion paints a picture of a particle that is not simply fast, but structurally incompatible with our experience of stillness. It lives in a mirror reality where the brakes are the accelerator and stopping is an impossible dream. However, a particle that moves infinitely fast is theoretically manageable. The true danger arises not from its speed, but from what that speed does to the geometry of time. The most unsettling aspect of the tachyon is not its speed, but its geometry. To understand the threat, we must dismantle our most basic intuition, the concept of now. We tend to imagine the universe as a synchronized clock where a single moment now happens everywhere simultaneously. If you snap your fingers on Earth, you assume that, at that exact same moment, a star is exploding in the Andromeda galaxy. But in the forensic architecture of space-time, this universal now does not exist. Physicists visualize space-time as a solid block, a loaf of four-dimensional reality. Your perception of the present moment is merely a slice through that loaf, a plane of simultaneity. According to special relativity, the angle of your knife, the angle of your now, depends entirely on your velocity. If you and I are standing still, our slices are parallel. We agree on what is happening at this moment. But if you start moving, your slice tilts. You begin to carve through the block at a different angle. For ordinary speeds, a car, a jet, even a rocket, this tilt is microscopic. The discrepancy between your now and mine is negligible. However, as velocity approaches the speed of light, the tilt becomes extreme. The plane of simultaneity rotates sharply, but it never rotates far enough to break the causal order. The speed of light acts as a geometric hard stop, a limit to how much your perspective on time can slant. It ensures that no matter how fast you go, you can never tilt your slice far enough to cut into my past. This is where the tachyon violates the zoning laws of the universe. Because a tachyon moves faster than light, with v greater than c, its plane of simultaneity tilts beyond the 45-degree limit of the light cone. Its definition of now is so radically skewed that it intersects with the past of a stationary observer. From a forensic standpoint, this is a geometric disaster. To a superluminal observer writing a tachyon, events that we consider history, things that have already happened and been recorded, might appear to be in the future waiting to occur. The sequence of events is no longer a fixed timeline. It becomes a matter of perspective. If before and after are simply coordinates that shift based on your speed, then the tachyon exposes a structural vulnerability in the system. If the geometry allows a slice of time to cut backward, what is to stop a signal from traveling along that cut? If now is no longer fixed, logic itself begins to fray. If the geometry of the tachyon is unsettling, its application is catastrophic. This brings us to the tachyonic antitelephone, a forensic reconstruction of a crime against logic, first proposed by Richard Tolman in 1917. Imagine a communication device that utilizes superluminal signals. You are on Earth and your partner is on a spaceship moving away from you at high speed. Because of the extreme tilt in your partner's plane of simultaneity as established in the previous section, your future is partially accessible in their present. You send a tachyon signal to the ship containing a simple command. Because the signal travels faster than light, it outruns the standard flow of time relative to the ship's skewed frame. The ship receives the message. Immediately, the ship's computer sends a tachyon reply back to Earth confirming receipt. Here is where the system crashes. Due to the specific geometry of special relativity, the return signal travels back along a path that, from your perspective on Earth, dips into the past. The math dictates that you received the ship's reply 1 hour before you sent the original message. You are now holding a confirmation for an order you have not yet given. This creates a closed causal loop. It allows you to make a decision that renders the timeline logically invalid. If you receive the confirmation at 11:00 a.m., you can decide not to send the original order at 12:00 p.m. But if you don't send the order, the ship never replies. If the ship never replies, you never receive the confirmation. The effect, the reply eliminates. The cause, the message. In computer science, this is an infinite loop that freezes the processor. In physics, it is a paradox that implies our current framework of physics is incomplete. Causality. The rule that inputs must precede outputs is not just a polite suggestion. It is the bedrock of logical consistency. If tachyons allow information to loop back and erase its own origin, then history is no longer a fixed record, but a system vulnerable to contradiction. However, the violation of time is not the only risk. While the antitelephone threatens logic, the physical nature of the tachyon threatens the very ground we stand on. In the cold logic of quantum field theory, the tachyon is not merely a traveler violating traffic laws. It is a structural warning light on the dashboard of the universe. To a particle physicist, the term tachyon often signals something far more dangerous than time travel vacuum instability. When we analyze the fundamental fields that permeate space like the electromagnetic field or the Higgs field, we look for their ground state, the state of lowest possible energy. We assume that empty space, the vacuum, is the bottom of the valley, a stable foundation, where the laws of physics are fixed. But the presence of a tachyonic mass term m² less than 0 in the equations indicates that the field is not at the bottom of the valley. It is balanced precariously at the top of a hill. Consider the metaphor of supercooled water. You can cool purified water well below its freezing point, and it will remain liquid. It looks stable. It acts stable. But it is in a state of metastability. It is structurally desperate to become ice. All it needs is a single nucleation point, a tap, a vibration, a speck of dust, and the entire volume freezes instantly. The liquid phase collapses into a solid phase. In the early universe, the Higgs field existed in a tachyonic state, perched at the top of its potential energy hill. This was a symmetrical but unstable configuration. Eventually, a process known as tachyon condensation occurred. The field rolled down the hill to a stable valley. This crash broke the symmetry of the universe, distinguishing the electromagnetic force from the weak nuclear force and giving elementary particles their mass. The tachyon wasn't a particle that flew away. It was the mechanism of the crash itself. Here lies the forensic threat. We cannot be certain that the Higgs field has reached the true bottom. Current measurements of the top quark suggests that our universe might currently reside in a false vacuum. We may be resting in a shallow dip on the side of the energy hill, not at the absolute base. We are the supercooled water waiting for a nucleation event. If a quantum fluctuation were to trigger a new tachyonic instability, a bubble of true vacuum would nucleate. The wall of this bubble would expand outward at the speed of light. This is not an explosion in the conventional sense, it is a phase transition. Inside the bubble, the laws of physics would be rewritten. The constants of nature, the strength of gravity, the charge of the electron, the mass of atoms would be reconfigured to a new, lower energy state. Chemistry as we know it would cease to function. Matter would simply lose its structural integrity. The scary part of this forensic profile is the speed. Because the rewrite wave moves at the speed of light, the information horizon itself, we would never see it coming. There is no warning signal because no information can outrun the collapse. The system would simply cease to be the current version of reality and become the next. If the universe is indeed this fragile, balanced on the edge of a tachyonic cliff, one must ask, why are we still here? Why hasn't the vacuum decayed billions of years ago? Perhaps our understanding of stability is flawed, or perhaps, as a new framework suggests, we need to stop fearing the tachyon and start looking at it from a different angle. For decades, the forensic consensus on tachyons was clear. They are mathematically allowed, but physically unobserved. They break causality, destabilize the vacuum, and create logical loops. But in 2020, a new line of inquiry emerged from the University of Warsaw and the University of Oxford, led by physicists André Dragan and Arthur Eckert. Their proposal does not seek to arrest the tachyon. It seeks to rewrite the jurisdiction of the court. Their argument posits a radical question. What if the anomaly is not the particle, but our limited perspective? In standard special relativity, we discard any reference frame moving faster than light as unphysical. Dragan and Eckert asked what would happen if we treated these superluminal reference frames as legitimate, valid viewpoints. When they expanded the Galilean principle of relativity to include observers moving at v greater than c, the mathematics produced a startling result. In their framework, crossing the information horizon c does not break the laws of physics. It flips the metric signature of spacetime. In our subliminal world where v is less than c, we exist in 1 plus 3 dimensions, 1 dimension of time and 3 dimensions of space. We are free to move in space left, right, up, and down, but we are prisoners of time, forced to march forward in a single direction. However, the equation suggests that for a superluminal observer, the roles of space and time are inverted. They inhabit a 3 plus 1 reality. To them, time expands into 3 dimensions, while space contracts to a single line of causality. This geometric inversion solves the mystery of the ghost. From the perspective of a superluminal observer, a tachyon is a perfectly normal deterministic particle, moving along a single path. But when we look at that particle from our subliminal frame, we are looking through the distorted lens of the information horizon. We don't see a single particle at a single location. We see a smear of probabilities. We see a field that seems to exist in multiple places at once. This looks suspiciously like quantum mechanics. The Dragan-Eckert framework proposes a unification that forensic physics has chased for a century. It suggests that the baffling weirdness of the quantum world superposition, indeterminacy, the particle-wave duality, is not random magic. It is the shadow cast by superluminal objects intersecting our reality. In this view, the tachyon doesn't violate causality. It adheres to a hyperdimensional causality that we cannot perceive. We call it random because we are missing half the data, the half that exists on the other side of the light barrier. If this model holds, tachyons are not rare monsters. They are everywhere. We simply call them by a different name, quantum particles. However, in forensic science, a compelling theory is not a conviction. While the superluminal framework is mathematically elegant, it remains a proposed framework, not established fact. We must apply a rigorous counterweight to this optimism. First, there's the issue of physical evidence. Despite the ubiquity of quantum particles, we have never detected a free tachyon, a particle clearly accelerating as it loses energy in any particle collider or cosmic ray detector. If the Dragan-Eckert model is correct, the transition between subliminal and superluminal states should leave a signature potentially detectable in neutrino oscillations. As of now, the data remains silent. Second, there is the superposition challenge. Critics argue that while the 1 plus 3, 3 plus 1 dimensional flip explains some aspects of quantum indeterminacy, it struggles to fully explain complex interference patterns, where particles seem to be in 2 states simultaneously in a way that allows them to cancel each other out. Mapping superluminal trajectories onto quantum wave functions is structurally promising, but the bridge is not yet fully built. The investigation is not closed. We have a suspect that looks less like a villain and more like a missing piece of the underlying code. But until we can observe a violation of the light barrier directly, the tachyon remains on the other side of the horizon, unseen, untouched, and theoretically terrifying. We began this investigation with a simple question: can something move faster than light? We end it with a much more profound realization. Speed is irrelevant. The true question is about the architecture of reality itself. The tachyon remains the ultimate cold case of physics. It is a suspect that fits the profile perfectly. It solves the equations, balances the energy scales, and appears to mirror some of the weirdness of the quantum realm. Yet it refuses to leave a fingerprint at the scene. We have built cathedral-sized particle colliders and stared into the deepest voids of space, yet the information horizon remains silent. From a forensic perspective, this silence leads to 2 possible verdicts. The first is that the speed of light is indeed an absolute firewall. In this scenario, the universe possesses a mechanism of chronology protection so robust that it simply forbids the existence of tachyons. The imaginary mass in our equations is not a doorway to a mirror world, but a mathematical error message, a sign that we have pushed the model beyond its breaking point. In this version of reality, we are safe from causal loops, but we are also trapped. We are prisoners of a single, rigid timeline, forever separated from whatever lies beyond the wall of C. The second possibility is far more unsettling. It suggests that tachyons could be real, but fundamentally unobservable in the way we expect. If the Dragon-Eckert framework holds true, then the universe is not divided into law and crime. It is a unified system where subluminal and superluminal are just two different camera angles on the same reality. We don't see tachyons speeding past us because from our perspective, they look like the probabilistic haze of quantum fields. The ghost isn't hiding. It is the building block of matter itself. This implies that the information horizon is not a limit of the universe, but merely a limit of us. Just as a ship in the middle of the ocean is surrounded by a horizon line, we are surrounded by the speed of light. We cannot see beyond the horizon not because the ocean ends there, but because of the curvature of the world we live in. There is an entire sector of reality, a symmetric faster-than-light counterpart that may be interwoven with our own influencing our vacuum shaping our probability, yet remaining forever out of causal reach. The investigation into the tachyon forces us to confront the humility of our position. We have spent centuries assuming that what we can see, touch, and measure is the totality of existence. But the math whispers that we are living in only half of the house. Whether tachyons are a glitch, a myth, or the hidden architects of quantum mechanics, they serve a vital purpose. They stand at the edge of our knowledge, reminding us that the laws of physics are not static commandments etched in stone. They are a map, and right now we are standing at its edge, staring into the dark, wondering what moves where time no longer flows forward. The case remains open.